So in this video, we're going to look at finding max and mins algebraically when we don't have a graph to look at. And so calculus allows us to do that because we know the relationship between max and mins and the derivative. So the first thing we would need to know is how to find these critical points, because that's where maxes occur and mins occur. So when the derivative is equal to 0, it's called that critical value or critical number. And we want to be able to find that. So to find that, if we're given a function such as x squared minus 2x, if we want to find the critical values, what we do is we take the derivative. So that's 2x minus 2. And then we set that derivative equal to 0, because critical values are where the first derivative equals 0. And then we solve it. So we get x equals 1. So this is where the critical value is at x equals 1. So this is a possible max or min. Now, we also want to be able to find sometimes the critical point. And so that's the point on the graph. So we have the x coordinate, that's we just found, where the slope is 0. But we also need the y coordinate. So to find the y coordinate, we always go back to the original function and plug in our x value. So we find f of 1 and plug that in for x. And we get -1. So my point is the x value, which is a, which is 1, and then f of a, which is -1, which is the f of x value. Okay, so why we do that is because we know that extrema on graphs either occur at endpoints or at critical points. Okay, so they're either at turning points, where is the critical point where the derivative has to equal 0 or undefined, or it's at an endpoint. And so we have this test called the first derivative test, which lets us find max and mins algebraically without looking at a graph. So using the idea that extrema only occur at critical points or endpoints, what we're going to do is we are going to first find those critical points. And then we're going to make a sign chart to help us figure out if those critical points or endpoints are max and or mins. So to find extrema, the first derivative test, we find the critical values by setting the derivative equal to 0 and solving. And then we know that those are the only possible places where there is a max or a min. It can't be like anywhere else, unless you have endpoints, and we'll talk about that in a minute. So then once we know where they're possibly located, then we make a sign chart. And if we find that our derivative changes from positive to negative, then our critical point is a max, because that means the slope changes from increasing, or from, means my function changes from increasing to decreasing. And so it's a max, or the slope changes from positive to negative. If the derivative or the slope changes from negative to positive, it means my function was decreasing and then increasing. So our critical point is a min. But if the derivative doesn't change sign, then there's no local extrema. It's going to be that plateau point. So let's look at an example. Okay, so to find the relative extrema, our first step is we take the derivative and set it equal to 0. So we get 2x minus 2. We did this before, equals 0. If you solve this, you get 1. Okay, and you don't necessarily have to find the y value unless they specifically ask for the critical point, or it depends if they say where or what are the extrema. If they say where, you just need the x values. If they say what are the extrema, then you do need the y value. All right, so this is my critical value. And this is the only possibility of where a max or a min could occur. So what we do is we draw our sign chart. Where we put 1 here, and then we know that the derivative is 0. And then this one splits it into two intervals, and you can write the intervals if you want, but we know that we have this one interval, negative infinity to 1. And I have my second interval, 1 to infinity. And we know that the derivative, the only place that it's 0 is at 1. So what we want to know is in each of these intervals, what is the slope? The slope is always going to be the same sign because my function is either increasing or decreasing in each of these intervals. So what we do is we pick some x value in this interval and we plug it into the first derivative and we see what the sign is. We don't really care what the number is, we just see what the sign is. And if it's negative, then we know our function is decreasing. And if it's positive, then we know our function is increasing. So my first interval is negative infinity to 1. So I'm going to pick a value. The easiest one is 0 in that interval. So I'm going to test point and find f prime of 0. Okay, I'm just picking any number that's pretty much less than 1 to be in this interval. So f prime of 0, I plug it into the derivative. I get 2 times 0 minus 2. So 2 times 0 is 0, and minus 2 is negative 2. So this is negative. So I'm just going to put a negative sign because it's negative. So from negative infinity to 1, the slope is negative and it's going to be decreasing. Now you can try any number, like you could try -2 or -1 or -10, anything in this interval, it should result with the same thing because the only time it's going to change sign is when it changes at 0. So it has to, the derivative can't change sign unless it goes through 0. And so once you find all the zeros, it's going to be the same in the interval everywhere else. So then we're going to try a test point in this interval. So again, anything between 1 and infinity, don't use 1, don't use the critical point, you're going to get 0. You need something that's not. So let's try 2. So I do 2 times 2, which is 4. 4 minus 2 is 2. Again, it's positive. I don't really care about the value, I just care about the sign. So that means it's increasing from 1 to infinity. If it's decreasing and then increasing, that means this is a min. If the derivative changes from negative to positive, this is a min. So to find the extrema, we would say, if they asked where, there would be a minimum at x equals 1. If they want the actual extreme value, then you need to find the y value. To get that, you plug 1 into the original function to get the y value, which we did when we did the critical point, which is -1. And so the minimum, if they ask for the point, would be 1, -1. Okay, and that's how you find the relative extrema.